Okay. Good evening, everyone. Just one more minute and then we will start. So, we are going to talk about module number 3, part 2, which is chapter number 7, and it's a continuous probability distribution. So, if you remember the difference between discrete and continuous, so last chapter we were dealing with discrete x values. Discrete x values means 0, 1, 2, 3, 4, 5, 6, more than, less than, fewer than, more than, and all such cases we were dealing. Here, continuous probability distribution, we are going to deal, any decimal value 1.2 to 3.2. So, minus 1.1 to plus 1.4. So, we are going to deal here in this chapter any possible value, even in decimal also. So continuous value, any continuous value. And therefore, this is continuous probability distribution. And similarly, we have uniform distribution that is not important. So you can go through, but I'm just starting the most important concept of this chapter. Area, like the in previous chapter you studied the entire, sum of all the event is 0. Probability of all the event is, sum of probability of all the event is 1. Here this area, entire area, this is also known as bell curve, this is also known as Gaussian curve, or this is also known as normal distribution. So the entire area is 1. Total area under this curve is 1. 1 is 100%. And similarly, we have PDF and CDF. So this is a PDF, and CDF will be like, increasing, reaching up to 100%. Now, here, this is the most important difference between chapter number 6 and chapter number 7. And this, like TT asked the question, on any single point in this chapter, the probability is 0. So whenever we deal the continuous probability distribution, we always discuss about one particular range, particular area, particular, 2 points. We don't discuss any value on one point. So for example, if I ask what is the probability of A, what is the probability of A? You need to give the answer 0. What is the probability of B, on point B is 0. If I ask what is the probability of between A and B, then you have to give the answer, 10%, 20%. But, on any point, on particular point, this probability is 0. Because in previous chapter, we looked, what is the probability of having 2 x equal to 2, we get some value. But in this chapter, we always look into the particular area. So suppose somebody says, what is the probability A? Means that is asking this area, up to A, means they are asking up to this area. If they say B or beyond B or something, that means they are looking this area. So please take care, because I asked one question in fill in the blanks also, and you need to think what question, and you need to give the answer. So basically, that is totally based on this concept. So this is the difference between previous chapter and this chapter. So probability between 2 points. So now after this, so same thing. Yeah, here if you, those who understand the mathematics or these notations, they can better understand what is the meaning of sum and what is the meaning of integration. So this is the difference also here uh, from. So you can see in discrete, we do the sum. What we do, probability of event 0, probability of event 1, probability of event 2, 3, 4, sum of all, and then we get the, here we do the integration in continuous from this range to this range, means from a, for example here, minus infinity to plus infinity, in this case a to b. So the range would be here a to b. So if you remember previous chapter, that is sum of all. Sum of all event, that is mu, and here is integration. So if you remember the, or if you notice these two sign, or if you understand the meaning of this sign, integration and summation, then you can understand. I'm not going into deep and detail about these things, but I'm going to explain, the application, so that you can better deal with problems and you can apply in your real life. So let's start with a standard normal distribution. Let me erase this. How can I erase? Where I Okay. And two important thing in this normal distribution, you always need to have mean and standard deviation. For dealing with continuous distribution, you need to always try to think mean and standard deviation. If you are able to do this, you can do everything. And you need to recall all the concept from previous chapter and this chapter. How do we calculate mean? How do we calculate the standard deviation? And we can do. So uniform, we we are not talking about uniform distribution, but I'm directly going on the normal distribution. It is called normal, it is called Gaussian, it is also called bell-shaped, and most important, mu and sigma, like I said, mean and standard deviation. And it ranges from minus infinite to plus infinite. That means, let me show you one. So if you see this, this part, they are not touching. They are not touching means they are going all the way to this side minus infinite, this side plus infinite, means its range is from minus infinite to plus infinite. If you see, they are very close to the base, very close to zero, but they are not. So very close to 0, 0, 0, but not zero. So it is like, you can keep drawing and you can keep drawing, but they are not touching. So the range of normal distribution start, but most of the, like you studied in chapter 4, this is empirical rule. Within my plus and minus 3 sigma, 99.73%. Means within this range, uh, which is almost 100%, 99.73% data or values reside within 6 sigma plus minus 3 sigma. So if you understand these few concepts, so like previous chapter, here mu and sigma, these two important, minus to plus infinite, this is limit, PDF is this. In Excel, we can do like normal distribution. Normal distribution, here you need to do 0, here you need to do 1, and rest is very simple. So if you understand this, mu, why mu plus minus? This is mean, mean plus 1 sigma, mean plus 2 sigma, mean plus 3 sigma, and similarly mu, mean minus 1 sigma, mean minus 2 sigma, mean minus 3 sigma. Within this, all 99.73, which is almost 100% data, is within this range you can find. So this is bell-shaped curve. Now this is lazy. Now we come to the what is normal, and these are few properties that you can read. Now, very simple thing. If you know this, this is called standard normal distribution. This is normal distribution. This is normal distribution, and this is standard normal distribution. That means every value is subtracted from mean and divided by standard deviation. And standard means every distribution mu equal to 0 and sigma equal to 1. Why and how? So if I can get the Titanic data right here, I can show you. Probably Titanic data. So probably, okay, I have to pull, just a minute. I have to pull the data from module 1 and I can show you this. So there is a nor standardized data based on this standard normal distribution. So I'm going to demonstrate to you, because in real life, people ask what is data, what is standardized data. So thing. Oh, I think I have this module number 2 has the Titanic data. So sorry, I was pulling wrong module. Okay. Okay, this is, can you see my uh, Minitab with Titanic data? Okay. So I'm just using this age variable, and let me do the standardized data. So I can say, and now look, I'm going here and we have option under data, and somewhere you can see the standardized. Here under calculate, you can find standardize, and you take the input column as and store results in C10. And now, so, if you can see, this is standardized, this is a standardized value, means it is plus or minus value. Why? Because mean is 0 and sigma is, or standard deviation is, always 1 for this data. And now I can demonstrate that.
Professor,
Yeah,
the standardized number, is that the z value that is
Eh,
referring to text?
yes, that's correct. This is a z value.
Thank you.
So for example, let's say if I take the average of entire age, let's say whatever average. So if I take 42, x value is 42 minus x value. If I take all these, average of all these, and standard deviation of entire this, data. So this is this value is this. And you can clearly understand plus value means it is more than average or more than 0. Means it is, so whatever is average, let's say 31. So if any number which is coming plus, that means its value is above average. So let's see how it works. Now I just demonstrate here histogram, and let's see, and standardized, and now you can see. Okay, so you can see standard deviation is coming 1 and mean is coming very close to 0, almost 0. This is almost 0, n equal to 2450. And if you see, and now we can do this for this, and we can do one manual calculation, and then we can proceed further. So graph, probability distribution, and graph, histogram. Okay, and let's do for age. So mean is, you can say 31, standard deviation is 12, and this value is 42. So just do a simple calculation. 42 minus 31 divided by, let's say, 12. So 11. This is mean, this is standard deviation. So this is z value. And this is 42 here, right here. So 11 divided by 12, which is coming almost point this value.
Hey, Raj, on your PowerPoint slide, you had said that that we should use 0 and 1 for the mean and the standard deviation. Was that
Yes.
just a starting point?
Yeah, for standardized normal distribution, always mean is 0. And
Except in this case.
this is, I'm just demonstrating how it is coming and what is the concept behind it. So
yeah, this example makes sense. I just wasn't drawing in the connection of when we were supposed to use 0 and 1.
So yeah, so this is normal distribution. This is normal distribution where you have, and mean is like 31, standard deviation is whatever number is coming from this. So this is, but when you convert this value into z value, so this is a z value here of this.
Right.
So when you have all the z on standardized scale, this standardized mean is 0, and its standard deviation is 1.
I got you. Thanks.
Okay. So so I was trying to explain. So this is how, this standardized value plus minus. Now think, like mu plus 1 sigma, mu plus 2 sigma, mu plus 3 sigma. Similarly here, mu minus 1 sigma, mu minus 2 sigma, and 3 sigma. Think about, just do the simple calculation. Mu for this, just take a normal distribution to check your empirical rule. Mu is 31. Okay, 31 plus 1 sigma. So sigma is how much? You see 12. And mu minus 1 sigma. So 31 minus 12. Look into that. What is the value here? 19. This is lower 19, and this is 31 plus 42. And this is plus minus 1 sigma. And now you can arrange this number in order and check how many values are there between 19 to 43. You will find approximately 68%, because plus minus 1 sigma is empirical rule, says about 68%. Since we have only 2,450 data points, it will not come accurately about 68%, but it will be close to that. But when you have like 10,000, 20,000 of data points, you will get approximately same value. So plus minus 3 sigma means 31 plus 3 into 12, which is how much? 31 plus 36, which is 67 is highest limit. Lowest limit is 31 minus 30, so which is about minus 6. From minus 6 to 67, almost 99.73% data will be here. So if you look into the data, we have only 3-4 values which are about after the age of 67. So this is just, I'm explaining the empirical rule, theoretically and practically. If you have real data or you are working in industry, you have real data to deal with, you can check yourself. Sorry, I didn't know. Okay, yeah, I'm going to make the, so this is the histogram of age U. So this is right here. Can you see my screen?
Yeah. Yeah, I
As-
got it. I think I got to that as well. Could you just go over actually how you got
Okay.
what column you did to get the mean and standard deviation again?
Okay. So go under graph and you have histogram, and this part, with fit. So with fit option, you do the age and you get the this. So you get this one. Is it clear? You?
Yeah, the mini tab on in the cloud is a little different. The selections are just slightly off.
Yeah.
Am I using the one that's a simple group overlaid or group displayed separately for the Y variable, or let's see, probably the simple one?
Yeah, this is the simplest one.
Simple, and then it's by age.
This is frequency, this is frequency, and this is age scale. And I have not selected the number of bins or anything. By default, whatever is coming.
Okay.
So, I mean, if you are using Mac or Apple computer or Chrome computer, probably, little bit difference in cloud version than this. But, if you are using Windows, you can download exactly the same application on your Minitab application on your Windows computer.
Yeah.
So, okay.
Yeah, I'm on Windows.
Okay, so you can download exactly the same, app on your computer.
Okay. Thanks.
And using EW login and password, you can just use. Okay, so yeah,
Oh,
this
I
is.
have a question before you move on.
Yeah,
how do
go
we-
ahead.
How do we upload spreadsheets into Minitab?
Okay.
Copy pasting isn't working for me,
Okay, so
and I'm in the virtual lab.
okay. Oh, you are using virtual lab. So you have Mac or you are using Mac or what?
A PC.
So you have PC, then why you are using virtual lab? If you have PC, then download on your
Because
computer.
the cloud doesn't have the same functions that you're using here.
No,
It's-
but you can download this exactly the same application on your computer if you are
Oh, it doesn't work for
PC.
me.
No, I will share the link exactly, Okay, I can just share so that you can I'm sorry. No problem. Minitab.
Yeah, I did that. That wasn't working for me. I'm able to do the cloud, which doesn't have all the features as the virtual lab.
No, exactly. I mean,
Hmm.
so you just, I think I will share the link in announcement so you can download because everyone is doing the same thing if you are Windows user.
Mhm.
So here we have app somewhere, cloud version. Here, this is a app. So I can just share this link right here, and you can just download this app minitab.com and keep following the same process.
Hmm.
And I mean, virtual lab is a little time taking process and it will take little time. But yeah, you asked the question how to, so first you need to put your file on either Google Drive or you need to put your file on virtual computer. Or you can download through email or you can put in because everyone has Google Drive from Eastern side. So you can import from there. You can directly just, open file and you can give the path to your Google Drive of EW and you can access the data. Okay, so
Yeah, sorry, that's not working for me.
not working. Oh,
Yeah, no.
because
Could you show me how to, instead of going through downloading, since I'm in the virtual lab, could you show me how we upload Excel spreadsheets? Because some assignments, like the Titanic
Mhm.
spreadsheet, I'm trying to upload it so that I can kind of follow you.
Okay, so I mean after this, I can explain.
Also,
So
Trisha, I think you should be able, if you're using the same one I am, I think you should be able to click the open in Minitab under file, as long as you save that spreadsheet. If you click open, you should be
Okay.
able to download that information into Minitab.
Okay. Yeah, it's not. Okay.
so oh,
The
that's
the other way to do it too, that I was doing on the cloud, Trisha, was just copying and pasting from the Excel doc and then just pasting into the Minitab. So that worked for me.
So
But-
when I'm in the cloud, I can copy paste, but when I'm in virtual lab, I can't copy paste, which is weird.
Interesting.
And in the virtual lab, as I think everybody notices, there's more functionalities in the virtual lab versus the cloud.
so the virtual, the exactly the same functionality you can download if you are Mac user, but virtual lab means you are just using virtual computer and you need to have the file there, or you can import the file, or you can open the file from Google Drive, or you can also save your file on Google Drive. You can make one folder where you just, for example, you go under virtual drive, virtual lab, open your canvas there, under virtual lab, download your file from virtual lab opening Canvas, and right from there, because that is treated as a virtual computer, so you just go under download and you can open your file. So
Okay, I got
basically
it.
you
It-
have
it-
to you have to do every function within that virtual computer, like
Got it.
so yeah, that works perfectly fine. But
I got it now. I'm sorry. I'm sorry to hijack.
no problem, no problem.
Class for that problem.
No.
Thank you though, everybody.
So yeah, this is a standard normal distribution, and which is Z. So here always mean is always 0 and SD is always 1. Again, minus infinite to plus, and the function is normal standard, and in Excel you can do this. Now, like I said, 0 is mean, minus 1, minus 2, minus 3, plus 1, 2, plus 3. Now, now the question comes here, what is the area between in normal standard deviation? Normal standard distribution. So this is very easy. So this is Minitab. Go under graph, go under probability distribution, and I'm going to demonstrate. Okay. So this is, here you can go under normal distribution. Yeah, this is normal. In normal distribution, when mean is 0 and the standard deviation is 1, that means it's a standard normal distribution. Okay, when you give, some value like, 31 or 8 or 12 or something, that means this is normal distribution. A standard and, difference you can now clearly understand. So this is, now I am going to show you few things. So X value, now if I give the X value, 2X value, so which is minus 1 to plus 1, minus 1 to plus 1. And you can clearly see this is so 68%. This is plus minus. I'm just demonstrating the empirical rules. So minus 1 sigma to plus 1 sigma, 68%. Similarly, graph probability distribution, go here, and I can go from minus 2 to plus 2, and you can see 95.45. So minus 2 to plus 2, and similarly I'm going to demonstrate. Now my question to everyone, this is 99.73% minus sigma, minus 3 to plus 3. So this is the value of 6 sigma. What is the value of 5 sigma?
Just a little bit more. Sorry.
No. Okay. So this is 6 sigma, means if I ask 5 sigma, that means 2.5 this side, 2.5 this side. If I ask 3 sigma, means 1.5 this side, 1.5 this side. If I ask any other value like, half sigma or 1 sigma means 0.5 is here, 0.5 minus side, 0.5 plus side. So 4 sigma is 95%, 6 sigma is 99%. What would be the value of 5 sigma? And you can see yourself. So this is the question most people in quality interview or quality control or quality management related interview, they ask this, and people simply do the, so 5 sigma is 98 or almost 99%. So basically, this is if you are quality operations person, you know what is the meaning of Six Sigma. Six Sigma means only 3 point some about 3 defects per million are allowed. Means in 1 million of products, only 3 can be defective or can be not up to that level of quality. So, for example, how many parcels are shipped by or delivered by UPS or FedEx? Only rarely, out of million, 1 or 2 or 3 are misplaced or having some problems. Every day, millions of flights landed and take off, and only once in few months you hear about some problem like Alaska or Boeing issue related problem or any runway slip or any accident related. But so these companies are following the Six Sigma and concept, basically the concept comes from here. Though Six Sigma philosophy was invented by Motorola. So now I go further. So basically any value can be any area can be identified or can be find. So what is the probability between this and that? Any 2 points that you can choose and you can. So Z curve, what is the value between 1.96 to 1.96? So basically this is based on the book and other thing, but you can directly use. So there are 3 ways to do it. One is putting the X value. Second is giving the probability, then you can find the X value. So I'm going to show you the probability, then. So now I can I need to find the value. Let's say 5% here. Oh, sorry, I did wrong. I have to do 0.05 probability distribution. 0.05 means 2.5 here and 2.5 here. Minus 1.96 to 1.96. You can also do the inverse value. So you can find the. Now, what is the application of this? Why we are doing all this, this curve, and what is the importance? And that we can understand from this example. Okay, now here is the example. So suppose somebody took any exam, GMAT or something, SAT, GMAT or GRE, or the average of all the students who appeared in that exam, average is 75, standard deviation is 7. And if John scored 86, in what percentile he will be in? So basically you can clearly understand the entire average of all the student is 75 and he is having 86. That clearly understand he is more than 50%, because but exactly we would like to know at what percentile he is in. So 86, 75. So we can do very simply. Sorry. And here you go under this graph, probability distribution, same. Now here instead of standard, you are going to give the values of mean is 75. Standard deviation, what is 7? And we are going to look, 86, value of 80. So X value is 86. And now you can get the answer, which is about 94 percentile. So based on all data, if you know the mean, standard deviation, and you want to see in what percentile that number will be. So 86, John scored, and he scored in 94 percentile because, before John, almost 94% of the mass or, masses scored less than John. So this is now how much percent, if John wants to score 95, if John wants to go in 95 percentile, how much point he missed? So I would like to know what is the cut point of 95 percentile. So I can go here, same thing. I can use this and I can go under this. I put here 95. Instead of this, I put 95. So now we can see. So 95 percentile, 86.51, and John scored 86. So only half percent or half point. If he would have scored more, instead of 86, he would have scored 86.51. He would be in 95 percentile, and he deserved like something. So basically, this is most important thing. And actually, I mean, all you are experienced people, all you are working professional, and I don't need to tell you about this thing, but when I teach to my undergraduate students, I give one example. What is the application of this in real life? And how do you apply in your real life? So I teach my undergraduate students, whenever somebody asks, when you face any interview and they ask, what is your expected salary? Don't say I need 50,000, I need 70,000 for this job. Just give that you need in top 10 percentile, top 5 percentile, top 15 percentile, and let them decide what is the industry average and deviation, and I deserve in top 10 percentile or top 5 percentile. Don't give the exact number, I need this and that. So you know better. Now I go further. So basically, this is the application of this. So 94 percentile. This is a traditional way when you use the appendix or this kind of standard normal distribution table that I learned in my past using the table to do all these calculations, but you have Excel. So let me demonstrate this to you also in Excel. Okay, here I put a normal distribution. So here you have normal distribution, and clearly you can see, these items you need for normal. X value, I need 86. Mean is 75. Standard deviation is 7, I believe. And yeah, it's a cumulative, so I need to know. And I put here, and exactly 94 percentile. So basically, you can do everything in Excel also, but you don't have that feeling which you can see here. Therefore, here you can see exactly what is happening. Excel only you can see the numbers. So you can do everything here also. Okay, so this is.
I have a question about
Yes.
Minitab versus Excel.
Mhm.
A lot of industry, or at least in the tech sector,
Mhm.
Excel is the main tool. I've
Mhm.
never heard of Minitab until this class, but
Mhm.
yet you're encouraging us to use a lot of Minitab.
Mhm.
Is is the reason because of the graphing capabilities that it just is easier? Or
Actually,
what's the push here for Minitab instead of Excel?
okay, there are 2-3 reasons. So if I teach, for example, the same thing, if I teach this normal distribution to you without Minitab, we can see the numbers, and you know, visualization is easy in Minitab to understand the concept. So basically, okay, everyone is not having mathematical background or that kind of acrobatic thinking to understand it very simply. So basically, this versus this, you can clearly see you have two pictures in front of you, which is easy to understand. So one is this, one is this. Second thing, and if you understand the concept, book has given you all the instruction very easily in the book, and those who are really interested to apply in practical life or professional life, they can easily use the Excel. And the second thing, I can show you just here, right here, Minitab. And 1 minute. So, and here, you see who is using a Minitab. And
Yeah, I looked at that in the first week when you introduced us to Minitab. I mean, a lot of companies use it.
yeah, all
I have noticed that the visual aspect of Minitab is really nice. I mean, that's a lot more powerful than Excel.
and actually the purpose is here to explain the concept so easily you can understand. I wish, if everyone is having the same, level, then certainly I would love to explain the Excel, because everyone is having the Excel on their computer. And Eastern is using Minitab from last 20 years, if I know correctly. Somebody told me. I'm here from last 6 years. So even Microsoft is, Microsoft developed Excel, MS Office, but they are also using Minitab. So, and it's easy, to be honest, for demonstrating. If you understand the way you understand, whatever way students can understand easily, we would like to demonstrate through that way.
Yeah, no, that makes sense.
So, okay, now we go to next part. So this is, you can find any area that you need. So like I explained, the 95th percentile or whatever number you want to see. Now, inverse I just explained. No, now we come to the previous chapter, normal approximation to Poisson and binomial. Remember that, when I showed you the tables, pi value is up to certain level. After that, binomial table is not there. Lambda value up to 20. After that, Poisson table is not there. Then, because, every distribution behave like a normal distribution when n equal to higher, when n value sample size is large enough, all the distribution behave like a normal distribution. So n equal to 16 pi, this is n equal to 16. After this, binomial distribution table ends. So basically it comes to normal distribution, but there is a condition. So this is the condition. So please remember, because many situation. So these are when n pi means n and pi is greater than equal to 10, n1 minus pi is greater than equal to 10, then binomial distribution also works like normal distribution. But for normal distribution, you need mu, you need sigma. How do you calculate? N multiply n pi is mu, n pi 1 minus pi is sigma. So before entering you have to calculate based on binomial, you have to calculate mean and standard deviation. Then you can deal. So first condition is this, second is this, and rest is same. Third thing is also you need to convert discrete scale to continuous scale. What is discrete scale? Like, you know, you are before 16, before 5, more than 2, less than 2. What is the situation in this? So look into this. So here you can see here more than 17th actually falls between 17 and 18, not 18. So basically, if you look into this, clear. So if more than 17th in discrete, it would be 18 and all above. But here it takes in between, not 18. So basically it is middle point between 17 and 18. So always less than 17 means 16 and 17. In between 16 and 17 is 16.5. So this is the X value when you do the normal approximation of binomial and Poisson, then you consider this X value, not 17, not 18, 17 plus 18 divided by 2, which is 17.5. So this always you remember. Okay, if this is clear, you can do the same thing. Only thing you need to do, mu and this. And n pi 13 to 16, this is 16. And similarly, Poisson distribution, mu equal to here, mu equal to lambda, sigma equal to square root of lambda. And exactly the same thing. So you have to convert lambda to average and square root of lambda to standard deviation and do the same thing. And X value also in between. So you can convert binomial and this to, now after that, exponential distribution. And this is widely applicable in rare to rare situation like earthquake, like different situation. Basically, it is a special case of Poisson distribution. If event per unit time follows a Poisson distribution, the time until next event follows the exponential distribution. For example, in last 10 years, 5 earthquake came in Hawaii. What is the probability that in next 6 months, what is the probability of earthquake in next 6 months or so? So basically this is the exponential distribution. Here, one situation is very simple. You don't need to do. Here, average is given. Lambda is given in this situation. And you need to do 1 upon lambda and rest is done by software. So let me demonstrate to you. So here, look into the patient insurance inquiry arrive at Blue Choice Insurance at a mean rate of 2.2 calls per minute. So basically this is nothing but a lambda. But if you see the previous, we need 1 upon lambda. So what would be the value? Let me pull the simple calculator. So 1 divided by 2.2, which is 0.4545. So basically we got this value. Now the question is, what is the probability of waiting more than 30 seconds? So this is given in minute. We are looking for second. So second is also can be converted into minute. 30 second is 0.5 minute. Now let's do the. So I go under graph probability distribution and look into this. I go under exponential. And now here scale is 0.4545. Okay, I'm not typing, and I need a value of x value 0.5, 0.5, because half minute is 0.5, and we need this value more than half minute. So, and we get the value 33%, 33.29. And so 33.29 or 0.3329. So basically, what is the here? We need mean is 1 divided by lambda. So basically, lambda is given. We need to convert into 1 by lambda, but make sure that we have to have same unit of information given and same unit of information asking. So this is exponential distribution. And after exponential distribution, we have the last distribution, which is called triangular distribution. And 1 or 2 questions are based on this, and which is based on standard deviation. One question is asking a standard deviation. So the shape of triangular distribution is like this. A, B, C, 3 numbers. So basically, if you have lower, A is lower limit, B is mode, C is upper limit. The mean is A plus B plus C divided by 3. The standard deviation is this, and you can find the area and probability. So probability distribution, and you can see triangular. And you can put A, B, C, like I can put here 20, 30, and 40. And now you can give the X value. Let's say I need 35 and beyond, and I can get this. You can see this is 20, 30, and 40, and I need the probability between 35 to 40, which is, so this is triangular distribution. So this is module number 3 and part 2. Now, please feel free to ask the question if you have.
Did you go over the last graph before the triangular one really quick? Like the steps to get there again? It was
Okay, so first thing, you just see this this slide. Actually, first, I mean, how I used to do, I'm telling my paper pencil way. So I make a sheet, and I put properties of all the distribution. This is the, like, this is the summary of the distribution. The mean is this, standard deviation is this. What is mean? 1 divided by lambda. Lambda is average. So always convert. First question is has average, which is lambda, and you need the value 1 divided by lambda. So 1 divided by 2.2. This is your value, and this is 0.5, which is 30 second is 0.5, and just rest. And it is asking more than 30 second. What is the problem? More than 30 second. We need on the right side, So this is very simple. We go under graph probability distribution, and this, and we have this question in earthquake terms in fill in the blanks. So you just need to, I think that is given in decade, which is 10 years, and asking, I think, 1 month or 6 months. So either you convert that into month or month into the decade. So here, sorry, we need exponential. Where is exponential? E This is and the scale is 0.454545. After dividing 1 divided by 2.2, this is the value, and threshold 0. Shaded area we need 0.5, and we need this, and we get this. And Heidi, you are asking, how do you solve if you are only given 2 variables that so you need to read the question, what is asking you. Sometimes, question is framed in that way that value is there, but you need to think. So for example, my age is twice the age of you, and and your age is this. Then you can simply calculate my age. Are you getting me? My age is twice the age of you, and your age is X. Then you can simply calculate my age is 2X. So, is it making sense, Heidi? So the same question is given there, and you know the formula. This is the formula here. This is the formula. You use this formula. So basically 1 is 0. I have given you the answer.
Yeah.
I wanted to hide that answer, but I gave the answer. So you can think critically. Anyway. Any other question? If no, then I would like to say a wonderful night. And
Hey, Raj, can I ask you
Yeah.
a question?
yeah, please.
Where does this recording post to?
Okay, here you can see, just a minute. So when you go under announcement of your course, do you see the announcement? Because no, it will be posted, in an hour or so. But all the recordings are there in announcement.
I appreciate that. Thank you.
Most welcome. If don't have question, then good night and see you next Tuesday.
Thank
6
you.
Bye-bye.
Appreciate it.
Good night.
Thank you.